Hi there. Today in class we looked at arithmetic sequences, and so I've selected two problems from your homework to demonstrate what we were discussing. First one is number 15, the second one is number 21. In number 15 we were asked to find the 4th, 6th, and 13th terms of a sequence given a particular explicit formula. And so taking a look here, this is my explicit formula. A of n equals 6 plus the quantity of n minus 1 times negative 2. And I like to call these the plug and chug problems, because when we're asked to find the 4th term, all we are doing to find the 4th term is taking that 4 and plugging it in for my n. And so in this case we'd have 4 minus 1, which is 3, times negative 2, which is negative 6, plus 6, which is 0. Okay, same thing with the 6th term. We take our 6 and we plug it into the n. Okay, so we have 6 minus 1 is 5, times negative 2 is negative 10, plus 6 is negative 4. And then for that 13th term, we're going to plug in 13. Okay, 13 minus 1 is 12, times negative 2 is negative 24, plus 6 is negative 18. Okay. So that's what an explicit formula allows us to do. The purpose of this is to be able to take a certain set of numbers, a particular sequence that we know, and we're able to predict then, based on that sequence, based on the common difference, the pattern that's occurring, what's going to happen in 4 terms, or in 6 terms, or in 13 terms. Or frankly, you know, we could use any term. We could find the 220th term, and we'd place 220 into the n's spot, and we'd be able to figure out what the 220th term is. And that's the nice thing about the explicit formula, is that if you're looking at a particular pattern, rather than having to continue that pattern, to extend that pattern out to the 220th term, that's going to take a lot of time. Rather than doing that, we write an explicit formula so that we can just plug in 220 and get what the term is. Okay? And so then number 21, we were actually asked to build that explicit formula. And in fact, we were asked to build a recursive formula as well, if the sequence is in fact arithmetic. So we're going to build that explicit formula that we were given in number 15. So number 21, our sequence is 22, 16, 10, and 4. Okay, and so first we have to determine, is this in fact an arithmetic sequence? Well, if it is, we should be able to find a common difference. And a common difference, it means that there is going to be the same number added or subtracted the whole time. If I don't have a pattern, if it's not the same number added or subtracted, then it's not an arithmetic sequence. And this means it can't be multiplied or divided either. That's not an arithmetic sequence, it's a different type of sequence. Okay, so I'm going to be looking, how did I get from 22 to 16? Well, I subtracted 6. And if this is in fact an arithmetic sequence, I should see minus 6, minus 6. That same pattern. Well, 16 to 10 was minus 6, 10 to 4 was minus 6. And so we do in fact have an arithmetic sequence. And that arithmetic sequence has a common difference of negative 6. Okay. And so we're going to use that fact then to construct our recursive and explicit formulas. Okay, so the recursive formula, I'm going to go ahead and put R for recursive, is A of n equals A of n minus 1 plus my d. And so for this particular sequence, this would make my recursive formula then A of n equals A of n minus 1 minus 6, because my d is negative 6. Okay. The unfortunate thing about the recursive formula is it's no better than just extending the sequence, right? In fact, it actually represents that idea, that if I wanted the 220th term of the sequence, I would have to go 4. Okay, minus 6 would be negative 2. That would give me my 5th term. Minus 6 from that would be negative 8. That would give me my 6th term. And you'd have to keep doing that out to the 220th term, right? That's a lot of time spent. That's what the recursive formula does. The explicit formula is nicer for those further away terms, like 220, because the explicit formula is what we were looking at in number 15. And it says A of n equals A of 1, which is going to be my first term, plus the quantity of n minus 1 times my d. And so for this particular sequence, I mean a of n equals, my first term in this sequence was 22 plus n minus 1 times my d, which was negative 6. And you do want to be careful with this explicit formula. When you have a negative difference, you need to make sure you've put that in parentheses. Okay? If you just put parenthesis n minus 1 parentheses, so the quantity of n minus 1, and you just put negative 6 sitting next to it without parentheses around the negative 6, it's not going to say times negative 6. If this negative 6 doesn't have parentheses around it, it's going to say minus 6, which is a very different concept. And so you do want to make sure you put parentheses around that negative 6. Okay, and so this one's a little bit nicer. Like number 15, if I wanted the 220th term, I just put 220 in there and plug and chug. That's arithmetic sequences.